Hello, my name is Dan Thornton from Thornton Economics. If you saw my previous video, I explained the negative relationship between bond price and interest rates by showing you that when you demand credit, that is, you borrow money, they're necessarily supplying bonds, and when you supply credit, you're necessarily demanding bonds. We're going to find that relationship in another way using a very simple example. Let's assume that you want to invest $1,000 and the interest rate is 5%. And so the question is, how much would you have at the end of a year? Well, the answer is you'd have $1,000 plus 5% of $1,000, or $1,000 times 1.05, which is $1,050. Well, we can ask the question another way around and say, well, what would you pay for a promise from someone to pay you $1,050 a year from today if the interest rate is 5%? And the answer is you'd pay $1,050 divided by 1.05, or $1,000 for that. Now, to understand the negative relationship between interest rates and bond prices, let's change the interest rate. So, for example, somebody promises to pay you $1,050 1 year from today, and the interest rate is 4%. How much would you pay for that promise? And the answer is it'd be $1,050 divided by 1.04, which is $1,009.62. And the reason, of course, is in order to get $1,050 at 4%, a year from today at 4%, you'd have to invest $1,009.62. Now, if the interest rate were higher, for example, 6%, what would you pay for the promise? And the answer is $1,050 divided by 1.06, or $990.57. And the reason, of course, is if you invested $990.57 today at 6% interest, a year from today you would have $1,050. This idea of present value generalizes. It's whatever the future payment is divided by 1 plus the interest rate, where the interest rate is expressed as a decimal. That is, 5% would be 0.05, 10% would be 0.1. Now let's get the idea of compound interest by considering what would happen if you invested for 2 years. So assume you invest your $1,000 for 2 years. The question is, how much would you have at the end of 2 years? Well, you'd have the $1,050 that you got at the end of the first year, plus 5% of the $1,050 that you got at the first year. You can rewrite that as $1,050 times 1.05, but the $1,050, of course, can be written as 1,000 times 1.05. And so the answer is it's 1,000 times 1.05 squared, or $1,102.50. If we ask the question in terms of reverse, in terms of the bond price, how much would you pay for a promise to receive $1,102.50 at an interest rate of 5%? The answer would be $1,102.50 divided by 1.05 squared, or $1,000. That is, you'd be willing to pay $1,000 for the promise to receive $1,102.50 2 years from today. The compound interest generalizes, though the equation generalizes. So the question is, let's assume you're 20 years old and you invest $1,000 and you leave it in, you never remove it until you retire at age 65. How much would you have? Well, you'd have the $1,000 times 1.05 to the 45th power, 45 years. So it's $1,000 times 8.985, which is equal to $8,985. Of course, the original investment would be $1,000. The other $7,985 is interest that you accumulated by leaving that $1,000 investment in for 45 years. This is sometimes referred to as the miracle of compound interest. So the future value is always equal to the amount you invest times 1 plus I raised to the nth power, where n is the number of years. I hope you find this explanation simple and understandable. If you want more information, please go to my website, dlthornton.com.